This is the 2013 higher level question C2. The graphic on the right shows an uplighter in the form of a hyperbolic paraboloid surface. Figure C2 below shows the planned elevation and end view of a similar uplighter. An isometric view is also shown. The surface of the hyperbolic paraboloid is generated by translating the parabola ABC in a horizontal position downwards along the parabola BD. B is the vertex for the parabola ABC, and D is the vertex of the parabola BD as shown. So part A of this question is to draw the given plan of the uplighter. So we're going to start with that. So what I've done here is I've just set out the general positions for each of these points. This is V1 and V2. Point B is down here, A, C, and so on. So what I'm going to do first is I'm going to draw the curve ABC. I need to draw that one first. I can't do much else without doing that. And that is based on a parabola. So parabola, I'm going to use the rectangle method. I'm going to divide each side up into a number of equal parts. So this is 90 long, so that breaks up evenly into 18. Oops. And this bit here, this half of this side breaks up again up into 5 equal parts of 15. Okay. So label our points. So this can A is 0, 1, 2, 3, 4, 5. And then down here, these lines are going to join to our vertex B. So these lines here then are going to be parallel to that, or parallel to the axis, sorry. And this is 1, 2, 3, 4, and 5 being the axis here. So what I'm going to do is going to join the lines from each of the lines here on the side up to the vertex, same way you draw any other parabola, same way you can do it for conics. Each one of these up to the vertex. Put the lines for 1 cross each other, that's the point of the curve, 2, 3, and 4. Draw the best curve that you can, that will join each of these points up. Back down to A, that is 1/2 of the parabola here. I'm going to mirror this across now, so you can do it two ways. You can redraw it on the opposite side if you like, or just use kind of an axial symmetry, taking them to the opposite sides, which is what I'm going to do. So point your compass on the axis, measuring the distance from here across the other side. Okay, and again, drawing the best curve that you can that will touch or go through each of these points. That gives us the first part of the plan, our parabola here. Next, what we need to do is we need to find the bit of the curve that's inside here. We're told that it is this wide, so going from this point to this point in the question, we just need to find how far up here that part of the curve comes. So it's a similar, it's based on translating this, so it's sliding down along. So what we need to figure out is, where is this parabola this width? So what we can do is we can just take this distance here, this width, and here on the opposite side as well. This here is the width of the parabola that we're going for. So if that's the width of it, this is going to be the distance that it's going to come out from up here back. So this is the width of it. That's the distance back that we're taking. So taking this distance here, that gives me the point that I'm looking for inside there. We can take other points, so I can take this point here, project them in. And again, measure the distance that they're from this line here back. That's the same line that we just measured from. Taking that one, give me a point here and on the opposite side. And can do one more as well if we wish. I have that line there already. Again, measuring from this line because that's the line that is where the parabola is that width. So this one along here, measuring that distance back and out from this end. And this is going to give us that same curve. So just adding in our two lines here. That completes the plan as asked for inside in the question. So having a look at the question again, part A there was draw the given plan of the uplighter. Next is going to be project the given end view from the plan. Okay, so we're going to go back to board. This is point B. We've now located this point in here, so we can take this one across and up into our first. So find this in our end view, projecting this up along here. This is now that same point down here in the end view. So our curve, our parabola is going to come down along here. Okay, this is what they call in the question point D. And point D is the vertex of this parabola. Okay, so we're going to draw our parabola up here. I've divided this side here up into 5 equal parts. This here is also going to be divided up into 5 equal parts. So here are our 16s. Okay, so again, this is our vertex, this is our axis down along here. Labeling our points 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 out along this way. B here is our 0, our start point. This is our axis, the line coming from D down to point 5. So these points down here are going to go parallel to it, these lines. And the lines from our side up here are going to join to the vertex. Okay, again, where the ones cross each other, points on the curve, 2s, 3s, 4s, join all of these back up. And this will complete our end view. So that completes part B of this question, drawing our end view. Having a look at part C is to draw the front elevation of the uplighter. So we're going to have a look at that part of that now. Okay, we know a few points. We know V1 and V2 here, they're points down here. And we know the top there is solid, so I can mark that part in. Now what we're going to have to do now is find the curve here and here. So this curve is based on this parabola and how that gets narrower as it moves down. So what we're going to end up doing is we're going to take distances from here. So we'll take different heights, different distances, mark them over here, and that will give us the width of this curve at a particular point. So what I'm going to do is I'm going to use the point 1, 2, 3, and 4 that I have down along here, just out of convenience. So I'm going to measure the distance from the back here, okay, or we can measure it this way. So from this point here back with my compass, that's this distance here that I'm measuring. Okay, this is the front of the parabola at that point. So what I'm going to do is I'm going to put that on the front of the parabola up here as well. So that's the same distance. That's going to give me the width of my parabola, or at that point. So the equivalent, that would be coming across here. So this point here is a point that is the width of the parabola at that point. So what I can do then is I can take this point and project that up into the elevation. Same point brought across, so the same height brought across from the end view, that gives me a point on that curve there. I can actually do the same thing on the opposite side. This width here, bring that up, and I should have brought this across further. That's that point there. So doing that again, measuring the distance, so this parabola, this large parabola ABC is sliding down along this parabola here. So I'm going to measure the distance from here back along, copying that distance onto down here. So that is the equivalent of how wide that would be at that point. So taking the distance, or from this point across to either side of the parabola, this is the equivalent width of the parabola at that point. Now I can project this up into the elevation 1 and 2. And again at the same height, that's a point here and a point here. So I'm going to do those for the other 2 points, or the other 4 points, and that will complete the elevation there for me. So again, measuring from the front here to the back, from the front towards the back, where it crosses. So that's this line coming across here, projecting this one now up into the elevation point and point here. So one more to do, that's this one again. So our parabola is after sliding down along the line BD here, measuring that distance. This is the equivalent distance of how far, this is how much of it is exposed at this level. The rest of it's all gone back further. So taking that line there, that width, this is how wide, or this is how essentially how much of the parabola is exposed at that height. And we can take this up now into the elevation, point and point. So that gives us all the points here on our curve. Joining, or it gives us a number of them, joining all of these up along, gives us the curve that we're looking for up along here. And there we have it. That is that curve coming up along here and up the opposite side. So the final part of this question is part D. The curves in the elevation form a portion of a double hyperbola whose vertices V1 and V2, whose focal points are located at F1 and F2 respectively. Determine the asymptotes to the double hyperbola in the elevation. So we have V1 and V2, and need to locate F1 and F2. They're here and here, they're directly underneath these points as given in the question, F1 and F2. So what we're going to do for our asymptote is we're going to take a line vertically up from the vertex, up along here, and our asymptote is going to cross through this point here in the center. One of our principles of the double hyperbola is that if we take the distance from this point here, from the point here in the center out to our focal point, and swing that around until it touches a line vertically above, or parallel to the axis here, gives us this point up here. That's a point on the asymptote. So this line here, that's 1, and the second one found the same way on the other side. So we can do this way, line up along, you can project it either across or swing the arc again on the opposite side. Same distance out here, swinging that around up, gives us our point here on the opposite side. So there we have it. That completes the 2013 higher level question C2.